let us discuss about atomic structure. According to Dalton, atomia, that is, tomia means divisible. Atomia means indivisible. Dalton, he gave this name atomia, that is indivisible, that is the finest particle. So the tiniest particle where it cannot be further divided, and he called that atomia. But after the discovery of electron, proton, neutron, that is, these are all subatomic particles, it is found that atoms can be further broken. So the question of indivisibility is a miserable failure, but still, just to honor Dalton, we retain this name atomia. Actually, the atom should be truly called tome or tomia, but it is an accepted error in science, so we still maintain indivisible, that is atomia. Okay, right. An element can be represented as X. At the left subscript you can have Z, that is called atomic number, and on the left superscript you have mass number. Then on the right superscript we have charge or the oxidation number. And A is the atomicity. Now let me explain about the Z. Atomic number is nothing but number of protons or number of electrons. Since number of protons is equal to number of electrons in an atom, it is neutral. So it can either be number of protons or number of electrons. That is called atomic number. Whereas A is the mass number. A is mass number, which is nothing but the number of proton plus number of neutron. Of course, this A can also be called, instead of NP we can include Z, replace Z, Z plus number of neutron. So this is an important formula where from we can calculate the number of neutrons also. So A is equal to Z plus NN, that is neutron number, and Z is atomic number. A is mass number, which is nothing but the sum of number of protons and the number of neutrons, where we do not include the electrons. So it represents the nuclear mass, right? Now, so we know what is element, atomic number, mass number, and the charge. Each element has its own charge when it is in its reactive state. For example, chlorine minus means -1 is the oxidation number or the charge, and O -2. So -2 is the oxidation number or the charge of oxygen. Okay, and then A, so we have discussed charge also. And in a neutral atom there is no charge. In a neutral compound or molecule it has no charge. Then atomicity is nothing but the number of atoms in a molecule. For example, let me consider H2O. So here Atomicity of hydrogen is 2. Atomicity of oxygen is 1. Let me consider H2SO4. Atomicity of hydrogen in sulfuric acid is 2. Atomicity of sulfur is 1. Atomicity of oxygen is 4 in sulfuric acid. When you are asked what is the atomicity of sulfuric acid, you have to add everything. So 2 plus 1, 3 plus 4, 7. Are you able to follow? Now, what is the atomicity of benzene, C6H6? Anyone? 12. Because carbon 6, hydrogen 6. Okay. What is the atomicity of carbon in, that is glucose, C6H12O6?
6.
So AC is 6. And what is the atomicity of hydrogen? 12 in this glucose. So I think now you are very clear about the atomicity. Okay. Right. Now let us proceed further. So when we talk about the atom, first of all, we should know that the central part of the atom is the nucleus. That we know. That will be very small actually. Very, very small. And the space occupied by the electron will be much more than that of the nucleus. So let me say here you have the nucleus. Inside the nucleus you have proton, neutron. So proton is positively charged, neutron no charge, neutral. But what about the outer space where electrons are revolving around the nucleus in an elliptical manner? So the electrons are negatively charged. So nucleus as such, it has positive charge. And what about this electron? Negative charge. So there is always an interaction between the nucleus and the electrons, and that is why these electrons are under the control of nucleus. And that is why we used to call the effective nuclear charge, means how much influence can be shown by the nucleus on the electron. That is called the effective nuclear charge. But we are going to discuss about the occupation of this electron. In fact, they will be occupying in different orbits. So naturally, the electrons which are in the outermost shell may be easily lost, and that is why we call it valency. So valency is the number of electrons available in the outermost shell. Now let me confine my idea about the atom with respect to a particular model. So when we talk about the atom model, as I already suggested, that is we have discussed the what you call the Dalton's model. Okay. So when we talk about the atomic models, take down atomic models. We have Dalton's model. Second, J.J. Thomson's model. Third, Rutherford model. Fourth, Bohr's model. Fifth, that is quantum mechanics, quantum model. QUANTUM, quantum mechanical treatment of mechanical model, you can say, quantum mechanical model. Okay. Now let us, we have already explained about the Dalton, and it was a miserable failure on the part of Dalton that the atom can further be divided. So that was one of the demerits of Dalton's atomic model, so that was disapproved. And later, that is J.J. Thomson, he considered the electrons are embedded like the seeds in the watermelon. So this is the watermelon model. Like in the watermelon, you have got lot of electrons, so you will be having a nuclear mass where the electrons are embedded. So this treatment is also disapproved because there is no, that is the energy transfer, all these things. And not only that, J.J. Thomson, he was able to find out the electron having negative charge, and there is a neutrality, that is the neutral state is maintained in an atom, and that is why there is no loss of energy as such. But these electrons are revolving around the nucleus in the circular orbit. So electrons around the nucleus in the circular orbit around the nucleus. So this is also, that is rejected. This was also rejected because when these electrons are revolving around the nucleus in a stationary orbit, what happens? It will lose its energy. When they lose its energy, then automatically it will come to the center and hit by itself. So that results the suicidal action of atom. So the atom will be destructed by itself, but according to law of conservation of mass, it cannot be destructed just like that. So this kind of spiral action will take place. So the electrons which are revolving around the nucleus will be reducing its radius, and finally, because of its spiral action, it will hit the central nuclear atom. So this was the failure of Rutherford, and it was a very famous experiment of Rutherford, that is the alpha particle experiment. So according to Rutherford's alpha particle experiment, he kept that is a gold leaf like this and passed the alpha particle, and some particles, that is, get bounced, and many of them, that is, passed through as though nothing has happened, and some of them get deflected like this. So he was able to observe, observation 1, 2, 3. One is bounced. It may be due to, because alpha particle is nothing but helium nucleus, that is positive particle. So when the positive particle hit the positive nucleus present in the atom, they get bounced. So it indicates the nucleus size is very small because only a very few percentage of alpha particles were bouncing. So from this is clear that the space occupied by the nucleus is very less, very less. Whereas some of them, as though nothing has happened, it go, but some of them, that is, they get diverted. It means because of the presence of electron, they are attracted. So he was able to infer that, that is, electron, because of the presence of electron, they are, that is, deflected. And in atom you have got plenty of space, enough space. So because of more space, these alpha particles, they went through the gold foil. This is gold foil. Went through the gold foil as though nothing has happened. So the space is huge here. So this third phenomenon or third inference is nothing but, that is, it indicates the huge space available in the atom. And here it indicates the presence of electron. Okay. So likewise, we were able to that is analyze based on his observations. But as I already mentioned, because of his that is circular orbit theory, there is a chance of a spiral action because these electrons will be losing its energy. So this self decay or destruction, okay, that is not acceptable. So we have rejected this Rutherford. Later came Bohr's atomic model, about which we are going to discuss in detail. Okay, right. So Bohr's model, take down. Bohr atom model. He suggested, that is, nucleus is at the center around which electrons are revolving in an orbit, and these orbits are, he made some assumptions. Take down. So electrons, and this is the nucleus part. Inside the nucleus we have got proton and a neutron. He suggested certain postulates. The energies of electron, the energy of electron of an atom is quantized. Quantized means we can count it, countable. So energy is unlimited, but that can be quantified. So he suggested the energy of electron can be quantized. Second thing, the electrons revolving around the nucleus in a circular path with fixed energy are called stationary orbit. So he introduced a term, stationary orbit. Stationary orbit. So stationary orbit means, that is, these electrons revolve. These electrons revolve in circular path around the nucleus. So you have to remember this term, stationary orbit, and here quantized, energies are quantized. And third, electron can revolve only in those orbits in which the angular momentum of the electron must be equal to the integral multiples of h by 2 pi. That is, the mvr, that is the angular momentum. Angular momentum. The angular momentum of electron. The angular momentum of electron is equal to mvr. It is given by mvr. Take down. Where m is the mass of electron, v is the velocity of electron, r is the radius of the circular path. Okay, because they are revolving in various orbits, various circular paths, circular orbits. So it has different radius, and this mvr is equal to, it is called the integral multiples of h by 2 pi, that is nh by 2 pi, where n is the integer 1, 2, 3, 4, etc. and h is called Planck's constant. H is called Planck's constant, and of course pi value you know, 3.14. Okay, so he described an electron which possesses an angular momentum will have the integral multiples of h by 2 pi value. Okay, so what is this MVR? That represents the angular momentum. You know something about momentum. Usually linear momentum is represented as mass into velocity, that is called linear momentum, but this is taking a circular path, so you need to consider the radius, so it is MVR, so that is called angular momentum. So here you can be sure about the angular displacement here, so angular momentum, take down. And the fourth concept, fourth postulate is, let me write here, an electron jumps from higher energy to lower energy. Electron jumps from one energy level to another energy level. Another energy level. So during this jumping, it means, for example, let me consider this is the first energy level, this is the second energy level. Let me say this is E1, energy possessed by the electron in the first level, energy possessed by the electron in the second energy level. Okay, now when it goes up, it has to get the energy, then only it can move. But when it jumps from higher energy to lower energy, it releases the energy in terms of photon, that is called h nu. So h nu. So when it absorbs the energy, the electron will jump to the higher place. When it comes back to the ground state, then it gives out the energy. So this change in energy, that is called delta E, which is given by E2 minus E1. So this delta E is given by h nu. Okay, note down this point. So from this he was able to obtain the new value. So E is equal to h nu. You can call this nu is nothing but delta E divided by h, where nu, h Planck's constant, nu is the frequency. Nu is called frequency. And h is Planck's constant. Its value is 6.626 into 10 power minus 34 kg meter square per second. Actually, Bohr's postulates were applicable Bohr's postulates are applicable to one electron species like hydrogen atom, helium plus. Helium plus means helium has 2 electrons. When you remove 1 electron, it becomes helium plus. Similarly, lithium has 3 electrons. When we remove 2 electrons, it looks like hydrogen plus. So, lithium 2 plus. So, based on his concept, we were able to obtain the radius of this circular orbit. It was given by r nth orbit is equal to 0.529 into n squared divided by z. Z is atomic number. N is the quantum number. So in this case, whether it is first energy level, second energy level, third energy level, n is the integer. It is given in Armstrong. Armstrong, 1 Armstrong means 10 power minus 10 meter. Okay. So this is a very important equation. So what is Rn? Radius of nth orbit. Take down radius of nth orbit. Z atomic number. N is the integer. That is nth orbit. First orbit or second orbit, etc. And based on that, we can work out the energy. So the energy is given as, that is energy of electron revolving in the nth orbit. Energy of electron revolving in the nth orbit is given by minus 13.6 into z squared divided by n squared in terms of electron volt per atom. So this is another important formula you must remember. And then now we can convert this into kilojoule per mole also. That is, energy possessed by the electron in a particular orbit is given by minus 1112.8 divided by n squared into z squared kilojoule per mole. Kilojoule per mole. So we will be discussing about this derivation of this energy in +2 under atomic physics. So you need not worry about the derivation, but you must remember the equation. Okay, right. Now the limitations of Bohr's concept. Take down limitations. Bose concept. First of all, not applicable to multi-electron system, because we have already seen that this is applicable only for one electron system. And in the multi-electron system, there will be more spectral lines obtained. So he was unable to explain the splitting of spectral lines. In the presence of magnetic field. Then he was unable to explain why the electron is restricted to revolve around nucleus in a fixed orbit. Unable to explain the fixed orbit of electron. Later, de Broglie concept was very well explained with that is wave particle duality. Let me explain about the dual nature, that is called wave particle duality of matter. So according to this concept, the very microscopic particles have the tendency to behave like a wave as well as particle. Sometimes it behaves like a particle, sometimes it behaves like a wave. So this kind of nature is called dual nature. So what do you mean by dual nature? Dual nature means that is showing wave nature and particle nature. Okay. De Broglie was able to explain clearly about this dual nature. He combined the Planck's quantum hypothesis and Einstein's mass energy relationship. De Broglie concept. So this concept is most famously, it is familiarly known as dual nature of electron concept. He was able to arrive this equation, lambda is equal to h by mc. So this is a de Broglie equation where lambda wavelength of electron, mass of electron, velocity of light, as I already suggested, he was able to get it from two equations. One is according to Planck's equation, E is equal to h nu. And this E nu is nothing but C by lambda. because C is equal to nu lambda. So we can replace this nu as, that is, E is equal to hc by lambda. And according to Einstein's equation, E is equal to mc squared. E is equal to mc squared. So he was able to compare these two energies. So he suggested hc by lambda is equal to mc squared. hc by lambda is equal to mc squared. So E is equal to hc by lambda. Another equation, E is equal to mc square. So LHS are equal, RHS can be equated, and therefore it is hc by lambda is equal to mc square. So C can be cancelled, and therefore you can bring this as h by mc is equal to lambda. So h is equal to lambda is equal to h by mc. And this is as far as particle nature is concerned. But when it behaves as a wave, C is replaced by velocity. This is the velocity of light. It means when the particle is moving at the speed of light, it has the velocity c. So velocity of particle, when it travels with the speed of light, that is equal to 3.0 into 10 power 8 meter per second. And velocity is normal velocity, velocity of particle, when it is less than that of the light. So C becomes V. Therefore he suggested this is for the particle of matter. So h by mv. We know already mv is equal to momentum. mv is called momentum. So we can replace this by h by p. Okay, h by p. Now let us solve some problems. Based on that, we can further be able to, we can further understand the concept behind this, that is dual nature. Take down, you can note down in your question bank. Problem. Calculate the de Broglie wavelength calculate the de Broglie wavelength of a 6.626 kg iron ball moving at 10 meter per second. Now let us calculate, excuse me, lambda is equal to what? H by mv. This is the formula. Given m is given 6.626 kg and speed how much? 10 meter per second. Okay. Now we know the Planck's constant. How much? 6.626 into 10 power minus 34 kg meter square per second. Now let us substitute. Lambda is equal to 6.626 into 10 power minus 34. You can write down the unit separately. Kg meter square per second divided by mass 6.626, that is kg, into velocity 10 meter per second. So first let us strike out the kg, per second cancel, and meter. So it results in meter. The unit is given in meter. And this one is 1. And this is simply 10. So it goes here. So it means 10 power minus 1. So it becomes 35, minus 35. So 10 power minus 35 lambda. So the answer is wavelength of iron ball is equal to 1 into 10 power minus 35 meter. Okay. You just imagine its wavelength is too small. When it is a 10 power minus 35 means very, very small. So do you understand this? Right. Now let us go ahead with another problem. Problem 2. Calculate the de Broglie wavelength. Calculate the de Broglie wavelength of an electron moving at 72.73 meter per second. Now let us work out. Lambda is equal to h by m v. So here h we know it is 6.626 into 10 power minus 34 kg meter square per second. M is how much? The mass of electron, 9.11 into 10 power minus 31 kg. This will be given as a constant to you. And then v, the velocity, 72.73 meter per second. Now let us calculate. Lambda is equal to What is asked here? Lambda is asked. So lambda is equal to 6.626 into 10 power minus 34, and the unit is kg meter square per second divided by. Always develop the practice of working out the units along with the main problem. Mass is 9.11 into 10 power minus 31 kg, and then velocity 72.73 meter per second. So this can be cancelled, meter, kg, so meter. And here that is 6.626 divided by 9.11 into 72.73 into this 10 power minus 34, and this becomes plus 31, is it not? So you get minus 3, is it not? So therefore now let us work out Six point 9.11 into 72.3 is equal to 658.65. That is equal to 6.626 divided by 658.653. Okay, now into, and this is minus 3, is it not, into 10 power minus 3, and therefore now 6.626 divided by 658.653 is equal to 0.01 into 10 power minus 3. That is, this is nothing but 10 power minus 2, and this is 10 power minus 3. So you can call it 1 into 10 power minus 5 meter. This is lambda of electron. Now just to compare these two values, the steel shot, which has the lambda 10 power minus how much? What was the value we got for electron? I mean for steel shot. For steel shot it is 1 into 10 power minus 35 meter, very very small, whereas it is almost appreciable, 10 power minus 5 meter. Okay, so it means the de Broglie wavelength is measurable and significant when it is very very small. Okay, so for the iron ball it is too small to measure, and therefore it becomes insignificant. So from this it's obvious that de Broglie concept is applicable for very minute particles, okay, in the atomic scale, right? Atomic or subatomic level. Okay. So let me summarize whatever we have discussed today. So initially we explained about the atomic models, and before that I was explaining about atomic structure, basically that is based on atom, atomia, indivisible, and we know how to represent the element with ZACA, and I explained about the, that is atomicity, and then later I was explaining about the subatomic particles. Then what are the different atomic models? Dalton, J.J. Thomson, watermelon model, Rutherford, the circular model, Bose concept, and quantum mechanical treatment. So here we discuss about Dalton, J.J. Thomson, Rutherford, Bohr, and we need to explain about the quantum mechanical model in our next session. And this is about the Rutherford alpha scattering. Rutherford alpha scattering experiment. Okay, so where we discuss about the incident of alpha particle on the gold leaf, thereby he was able to get the 3 inferences. And then I was explaining about the Bose concept. So in the Bose concept, that is we discuss about the different postulates. Okay, just a minute. So we were explaining about the Bose concept here, where I was explaining the postulates, different postulates of Bohr, and then the keywords are quantized, stationary orbit, angular momentum, and the Z equation, then the jumping of electron, and how to represent the delta E value, based on that how to obtain new value, then radius of nth radius of orbit, and then based on that how to obtain the energy. Then this is the energy, and then energy in the nth orbit, energy of the electron in the nth orbit, and then En is equal to minus 1312.8 divided by n squared into Z squared, where Z is the atomic number. So this is given in 2 units. One is electron volt per atom, another is kilojoule per mole. So you have to be careful about these values. And we explained about the limitations of Bohr concept. Okay, so it is not applicable to multi-electron system. Unable to explain the splitting of spectral lines. Then he was unable to explain the fixed orbit possessed by an electron. Okay, and then we explained about the particle and wave nature of matter. Okay, so wave particle of matter, dual nature, showing wave and particle nature. So here we were explaining about the de Broglie concept, lambda is equal to h by mc, and I was explaining about the correlation of this Einstein's equation and the Planck's equation, and based on that he was able to get the value. Then we were able to work out these 2 important problems here, and we got this equation, that is lambda is equal to h by mc, then how it was replaced by h by p, and we were explaining about these 2 problems. One is with iron ball, another is with electron. So from these 2 values here we were able to get 1 into 10 power minus 35, which is almost immeasurable, whereas in this case it is appreciable. So de Broglie's concept is applicable for the microscopic, that is micro level, that is subatomic level particles or atomic level particles, for tiniest particles, not for macroscopic particles. Okay, right.